Dr. Tamer Muhammad. Dr. Waqari, are you with us?
Yes, I am. Hello? Can you hear me?
Can you kindly share the screen with us, please?
Can you hear me?
Yeah, we can hear you. Just if you can speak up a bit.
Okay. I hope my voice is clear.
Can you share your presentation, please?
Okay. But host disable the participant screen sharing. Can you enable the participant screen sharing?
I'm sorry, I can't hear you.
Can you enable the participant screen sharing?
No, we will start with you actually now.
Okay.
All right.
But I cannot share my screen.
Yeah, you can share your file if you wish. Yeah.
Yes, I am now
All right.
opening my file, but okay, now it's up.
I believe now you can, yes?
Oh,
Yeah.
can you see my file?
Yes. Beautiful.
Okay. All right. Thank you.
All right. Good morning, everyone. Well, like to start the day today with our first presenter here, Nuruddin Waqari from Malaysia. Dr. Waqari will be talking about the conversion of oil by palm empty fruit punches waste to activated carbon using superheated steam. A very interesting topic. The floor is yours, so you can start. Right, you have about 10 to 15 minutes, please.
Thank you very much to the organizers. Thanks for the introduction. Just to inform you that I am actually not the person who should be I'm just the co-author of this paper. My name is Izhar actually. Sorry. I will be presenting on behalf of this Dr. Waqari because he is not here now. The topic I'm going to present is about the conversion of oil palm and fruit bunch waste to extract carbon using separated steam. This is the oil palm biomass. If you can see, this is the tree, as you can see at my background as well, the same tree. This is the palm oil. Okay, the oil palm tree consists of 10% oil and 90% of biomass, but it can be categorized to three. Okay? The oil front, the palm front, which is the leaves, okay, and then the fruit bunch, which contains the oil, and also the palm trunk. So the oil is based mainly in the fruit bunch here, which is the crude palm oil and the kernel palm crude palm kernel oil. And this is only the oil that can be used, and the others are the palm shell, the pressed mesocarp fibers, and the empty fruit bunch, and also the liquid are all considered as waste. So only 10% becomes oil, and the others are all waste. So this waste is quite a lot. 90% is waste, and why not we consider to the study is about to convert this waste into a value-added product. So in this case, in this study, we have considered the use of this empty fruit bunch, the one that has been pressed, the oil without oil, and convert to something like such as activated carbon using superheated steam. So actually the waste is quite a lot, and you can see the figure here which shows the empty fruit bunch. If not done anything, then you can see a very major disposal problem, okay, which can affect human health and environment, and also maybe some environmental issue as well. So in order to convert this waste into activated carbon, there are two methods. One is to use the chemical treatment, okay, and the other is to use the physical treatment. So the chemical treatment is normally the conventional method where we use acid or alkaline, okay. And also the physical treatment, for example, in this case we are using physical treatment, so we are going to consider the use of carbonization in activation to keep, okay, the waste just now, the empty fruit bunch or the EFB, into something valuable such as activated carbon. Okay. So why do we use superheated steam? This is because there are advantages here. The superheated steam reacts 4 times faster and creates more surface area into the carbon, so very suitable for activated carbon. And also it has a faster drying speed, okay, and no oxidation because there's no oxygen content. Okay, so the objective here is to investigate the effect of superheated steam in activated carbon produced by observing the surface area, okay, and to evaluate the physical properties of the activated carbon, such as the moisture content, the volatile matter, the ash content, the fixed carbon, and also to examine the functional group on the surface of the activated carbon using FTIR and classify the liquid components using Gcms. Okay, so this is the equipment setup. You can see here the equipment setup consists of an evaporator. Okay, the evaporator will produce the superheated steam, and then this is the body surface. This is the kiln. Okay, the kiln where the waste just now is placed inside this kiln here and heated with the superheated steam, and to produce the activated carbon, and also to remove some of the moisture or the liquid to be condensed here at the condenser area, and we will get product, the solid product and the liquid product as well as the gas product. Okay, but based on our study, we have not observed any gas producing outside here, so that means here we will only consider the solid and the liquid product only. Okay. So the temperature profile of the kiln for the carbonization and the activation is shown here. So this is the time, okay, the time, and this is the temperature of the kiln, okay, the carbonizer. Okay, so first, the drying process, okay, which is up to 100 degrees Celsius, and then the torrefaction and carbonation increase up to about 400 degrees Celsius. Okay, here, and then we activate, okay, we activate the filler just now up to about 600 to 800 degrees Celsius, and then we cool down. So there are a few steps here. Okay, and the flow rate of the steam is about 3 milliliters per minute. Okay, so this will be the estimated reaction that is going to be inside the kiln. So the biomass or the waste, the EFP waste just now will be is reacted with the steam, the superheated steam, and to supply the heat and to produce the char or the activated carbon, plus the bio oil in liquid form, and also the pyrolysis gas. Okay. And the activated carbon or the char here, the solid waste, the solid product here will be we will analyze the mass yield, the surface area, the proximate analysis, and the surface functional group. Okay, so the proximate analysis will be the moisture content, the volatile, the ash, and the fixed carbon. And the liquid, okay, that is produced as well here as in the bio part here will be checked using a Gcms. Okay. And so this is the actual temperature profile of the kiln and the body furnace in the carbonizer. You can see here as we have predicted, okay, there's the drying, okay, dry up to 100 degrees Celsius. This is the actual temperature, okay, of the waste just now that was heated using superheated steam. So the drying is about 100 degrees Celsius as expected, and then torrefaction up to 400 degrees Celsius. Okay, and then the activation. Okay, so here we did activation for 500 degrees Celsius, 600 degrees Celsius,
Mr.
700
Waqari,
degrees Celsius.
can
Yes?
you kindly do a slideshow, please?
light show.
Yeah.
Oh.
Down there, yes.
Actually,
There
if
you
I
go.
do such show, it
yeah.
will crash. My computer will crash.
It will
I'm not
crash?
sure why.
All right.
Yes.
Oh,
You see,
okay.
it will crash. So I cannot. Sorry, I'm so sorry.
Yeah, you can go back to the PowerPoint file.
Okay.
That's good.
All right. Okay.
Sorry about that.
Wait. It's okay. Can you see now? Not yet.
No, not yet.
Okay. Can you see now?
I can see you're sharing your screen. Yeah, there you go.
All
Yeah,
right.
you can proceed. Thanks.
All right. So sorry, I cannot do the presentation slide because of the crash just now. Okay. Okay. So I continue with the result and discussion. So these are the results of the after decarbonization. You can see here. This is the raw empty fruit bunch just now that was taken from the mill. Okay, this is the raw before the treatment. And then when we treat up to 40 degrees Celsius, you can see the color. The color becomes from brown to black. Okay, and then it becomes smaller at 5 degrees Celsius, and then becomes smaller and smaller up to 800 degrees Celsius. Okay, so this indicates that the hemicellulose, the cellulose was not completely hydrolyzed here, and then as the temperature increases, it becomes carbon. So this is a more brittle. The size is about 0.1 to about 2 millimeters, and more brittle. And this is considered as the active carbon as what we have trying to produce. Okay. So the activity carbon that we took just now, we checked for the surface area using a BT. So this is the temperature of the treatment temperature. Okay, this is the surface area. So we can see as the temperature increase, the treatment temperature increase, we can see the increase of the surface area of up to about 500 square meter per gram. So this shows that we are able to produce a very good active carbon. Okay, and also we can see there is an increase in the micropore surface area, the volume, the volume, and also the total pore volume. So all are increased. So this shows that we have succeeded in producing active carbon based on this BET method. And for the proximate analysis of the active carbon, okay, we also sent for the moisture content, the volatile matter H content, and the fixed carbon. And this figure here shows the temperature of the treatment temperature. And this is the content in percentage. So you can see here the before treatment, the raw material, which is before the treatment, you can see the moisture content is very high, more than 50%, okay, and the volatile matter is about 30%, and then H content 4%, and fixed carbon is about 11%. So as we increase the temperature up to about 800 degrees Celsius, you can see all of the moisture content becomes very low, up to less than 1%, about 1%, and then the volatile matter also reduces from 30 to about 90%, and also the H content reduces from increases from 4 to about 8%. Okay, and also the fixed carbon increase from 11 to 71%. So this here, 800 degrees Celsius shows the best condition, okay, or the successful of our method to produce active carbon as compared to the method by other researchers. Here, as you can see here, this figure at the end here shows the active carbon that is produced from nitrogen. So it's about the same. Okay, then this is the active carbon treated with separator steam, the STIR figure. Okay, this shows that the increase of oxygen functional groups such as carbonyl, hydroxyl, okay, on the surface of the active carbon when the temperature increased from 400 to 800. Okay, so you can see here the increase of the oxygen functional group. Okay, so this is the GCMS for the liquid product. Sorry. As you can see here, this is the figure of the spectrogram of the Gcms, you can see there are many peaks here, there are many components inside the bio oil. And the main component that we can find here is formic acid, ethyl ester, acetic acid, and propanolic acid. So that's why we have the pH to become slightly acidic, when temperature is increased. And this shows here, this table here shows the comparison between mangrove wood that was used, the superheated steam that we use mangrove wood, and also the EFB. Okay, so with mangrove wood as well, we produce acetic acid, butanoic acid, and phenol, as well as the using our EFB, current EFB, we also produce the same thing. So that means we have about the same product, for mangrove wood and the EFB. So as we can conclude here that the treatment by superheated steam has a high potential to recover byproducts, and treatment using nitrogen gas. And water has a high condensation point compared to inert gas, making it easier to recover condensable products. So as a conclusion, this is from the reaction just now from the biomass or the EFB plus the superheated steam, we produce char in solid, bio oil in liquid, and gas. So from the char or the activated carbon, from the char we produce activated carbon, which is brittle black, and the yield is about 16%, and the high surface area of 475 square meter per gram, and with a very good quality of the activated carbon, and also from the FTRI, we also confirm that the high hydroxyl and carbonyl group produce negative surface charge activated carbon, and suitable for absorption, for example, absorption with methyl blue. Okay, so the black part here is where you can see that the superheated steam was able to remove the large dissolved organic molecules and small organic molecules, and to relieve the very high porosity of the activated carbon. Okay. As for the liquid, the bio oil, the liquid, we also confirm that there's a high acidity, which means high in acetic acid, and this is suitable used as an organic pesticide in agriculture industry. So we can reduce. So with this product, we can reduce the chemical substance consumption. Rather than using the chemical that is normally used in the industry, we can also use the waste from palm oil, to produce pesticide. Okay. So finally, our study has shown that we have successfully converted the waste EFB to value-added products. We were able to reduce oil palm waste in plantation, to produce a better, highly value product, and also by using superheated steam as a medium, we have produced good quality activated carbon. So that's all for my presentation. Thank you very much.
Well, thank you very much, Mr. Wakari. I have a question for you, actually, but before that, I will leave the floor to the audience if we have any question from the audience here. Any question? All right. My question to you is, why the selection of the empty fruit punch? I mean, what do you guys do with it now, before this process?
Okay. Before this process was introduced, this EFB, the one we have using here, this is normally returned back to the plantation. The plantation, as you can see at my back here, returned back as a compost. That means to return back and reuse again the nutrients inside the EFB. But a more value-added product can be produced. So we think that, so that's why we try to change. Rather than just return it back to the plantation, we might able to produce something that is highly priced. So, for example, activated carbon. So that is why we have chosen this empty fruit bunch to produce to treat with superheated steam.
One more thing. For the raw material, do you do any processing before that, or you just use the raw material as is to produce the biomass, to obtain your biomass?
Okay. Okay. Before the empty flue bunch here is after it has been pressed. So the oil has been removed. So the remain here is only the bunch without the oil. Okay. So with this we just use it as it is inside our process. So there is no pre-treatment.
Thank you very much. Thanks.
Okay.
Thank you very much, Mr. Wakari. Next is Nurulaina Safi from Malaysia also. We'll be presenting a paper about the nutrient recovery from hybrid adsorbent through the application of slow-release fertilizers. It's a mini review. Safi, are you with us?
Hi, can you hear me?
Good evening.
Hello?
Well, it's still good morning in Jordan.
Hi, good morning. Yeah, I'm from Malaysia, by the way. So I'm going to share my screen right now. Is it okay?
I'm sorry?
I'm going to share my screen.
Yes, please do.
Right now.
Yes, please do.
Okay. Alright, Assalamualaikum and a very good morning to everybody. I'm going to present on the title, which is as mentioned before, which is on the nutrients recovery from hybrid adsorbents through the application of slow release fertilizer, which is a mini review. And I'm Liana, by the way. Okay, so as introduction, this is actually related to sewage, which is on average it contains 40 milligram per liter of ammonium ion, and hold on. Okay. Contains approximately 15.2 million tons of ammonium per year that can be recycled into fertilizers. Recovering P, phosphorus, from sewage can satisfy 18% of the world's demand. These species in sewage can generally be classified as inorganic phosphorus, polyphosphate, and organic phosphorus. The N compounds mainly exist as ammonium nitrogen, NH4 plus N, as we know, and derived from two sources, which are from the effluent and written liquid from activated sludge process. Normally, a typical effluent contains 30 to 40 milligram per liter at pH of 7 to 8 at temperature of 20 degrees Celsius. The nutrients removal process is usually being applied in tertiary treatment, which is actually rare, very rare in sewage treatment, through the adsorption process. Mainly use activated carbon, just like our previous presenter. They actually use the activated carbon to treat ammonia, nitrogen, and any small ionic compounds. Natural adsorbents, namely natural zeolite and biochar, have been widely applied and tested to remove nitrogen and phosphorus. High concentrations of nutrients in the sewage can be recovered by the adsorption process and can actually be recycled into many useful agricultural purposes by reusing the adsorbents. So according to FAO, 200 million tons of fertilizers are actually needed by 2032 to sustain the population demand. So imagine in 2030, 2050, now we're going on 2050. So imagine how many fertilizers that we actually need to sustain the population demand. The synthetic fertilizers are lost by 55 to 70% through leaching, photodegradation, chemical hydrolysis, and microbial decomposition, which means that not all synthetic fertilizer can be used 100% by the plants because it's actually lost through these processes such as leaching, photodegradation, and etc. So slow release fertilizers, which I will continue by representing this as SRFs, okay, are not specifically designed to have a certain period to release the nutrients and subject to the changes in soil type and climatic conditions, while for CRFS, which is controlled release fertilizers, the pattern, quantity, and time of release can actually be predicted within the limits for CRFS. Application of composite adsorbents as the organic SRFs is desirable as it can improve soil fertility without polluting the ground and surface water, as well as cost-effective. Coatings such as sulfur and polyethylene was used initially as a coating for SRFs or CRFs, but it has low wettability and adhesion to the coated oil, requires conditioning materials to reinforce its sealing. So hence biopolymers such as alginate, chitosan, and tapioca starch have been used as an environmentally friendly coating for SRFs and CRFs. It is reported that CRFs and SRFs result in longevity of end release from the final product. So this is actually an illustration of SRFs and CRFs mechanism. As you can see on your left, which is SRFs NPK encapsulated. The nutrients actually encapsulated in the slow release fertilizer. So once you put it in the soil, okay, all these nutrients will go to the plants while it will remain on the soil, in the soil. Okay, so this is how the SRFs works when you actually use this in the soil. Okay, so actually there are many nutrient recovery methods. For example, direct use from urine. Okay, we can use air stripping, evaporation and drying, also precipitation of P and distillation of ammonia. So air stripping has high efficiency of ammonia recovery, which is up to 95%, but it has low P recovery, which is larger than 33% only, and requires precipitation process. It has also high cost of operation, and then for evaporation and drying, it can reach up to 70% to 95% for both nutrients, but it depends on pH and requires high volume of sulfuric acid to maintain pH. And then precipitation of phosphorus and distillation of ammonia, so it can reach up to 95% of phosphorus recoveries, but you can only get 3% of nitrogen. So pH is needed to increase to 10 to get more in ammonia. So we need more sodium hydroxide, for example, to increase the pH. And then it produces large and longer hydraulic irritation time combined with sedimentation or filtration is required to increase the efficiency. All right, for synthetic solution, just now I explained about urine, recovery nutrients from urine. So now from synthetic solution, there are certain lab scales that have been done using Struvite Precipitation with adsorption, desorption, which is most famous methods to recover nutrients from adsorbance, which is desorption. Zirconium encapsulated chitosan quaternized beads, desorption chitosan bentonite, and also EFP-SRF. All right, so start from Struvite Precipitation. Actually, Struvite Precipitation is quite wide in this industry where they actually precipitate phosphorus. But actually, you need a very high concentration of phosphorus in order for you to precipitate it. Okay, and the mixture of Struvite and natural mineral adsorbent has got a good nutrient qualities and can be used as soil conditioner. While for adsorption and desorption, it can actually recover 38 to 48 milligram per gram and reusable up to 8 cycles. That is actually one of the advantages when we use adsorbents because it can reuse up to 8 cycles. The hybrid adsorbent has lower AC at higher pH, which is 7 to 12, while high AC at pH 3 to 7. As the surface charge is more positive at lower pH and more negative at pH larger than 7. So when we deal with any adsorbents, actually we're talking about surface charges, and the surface charges actually influence its reusability or adsorption capacity towards any nutrients. So we have to be really careful with adsorbent. That is one of the advantages. Also weakness if you don't know what exactly the surface charge of your adsorbents. And then zirconium encapsulated chitosan quaternized beads can also recover nitrates up to 80.2 and phosphate up to 67.7 milligram per gram. However, it is an exothermic process. Followed by desorption, chitosan bentonite can actually recover phosphate up to 196 milligram per gram, and it can easily be generated using 0.1 molar NaOH, but the performance is actually dependent on the pH. And EFP-SRF actually can recover ammonium ion up to 73%. This one is raw EFB, empty fruit bunch, and it has been used as slow release fertilizer in the soil. Right after it cannot be used in water treatment, then we reuse this EFP, but it is a very slow process. So recovery of nutrients using hybrid adsorbents. Now everyone, if you in this field. Actually, the current research is moving towards a hybrid adsorbents instead of single adsorbents, such as only zeolite, only hydrogen. So actually, they are hybridizing these adsorbents. Adsorbents can easily be regenerated by inuents by using eluents such as sodium hydroxide, KCl. We can also use multi types of salts. Use natural zeolite as a slow-release fertilizer. There has been usage of natural zeolite as slow-release fertilizer. There is an improvement in number of leaves and acidity of strawberry fruit, though it is a very slow process. The submerged plants can be used as a media for plant growth later, such as just now I explained about the EFD that can actually serve as a medium for plant growth, and direct application of ammonium-loaded biochar to soils as fertilizer are possible, as confirmed by similar research with the growth of water spinach. All right, as a conclusion, this is a very mini review. Okay, the recovery of nutrients mainly being done on a lab scale by using urine and synthetic solution. If so far you read the review, there's very less like large scale application on the recovery of nutrients, even though it can has many advantages and it can actually cover many sectors such as agriculture, wastewater treatment, and also you can reuse the water bag and etc. Nutrients recovery from urine is high and chemical precipitation is mainly being used that eventually it will form struvite that can be used as fertilizer. This process dependent on pH, a complex and energy-intensive process. However, the drawbacks of using urine directly and repeatedly could increase the pH of the soil by 0.5 and electrical conductivity by 100 micro-s per centimeter. So in this case, it will actually affect the pH of the soil and eventually it is not suitable for any plant to grow. The direct application may also increase the possibility of pathogen contamination, such as direct use of sewage and associated diseases, which in return will affect human as a consumer. So that's why we are actually considering on using the adsorbent, but not direct application of it because of the pathogen contaminations. Other than this option, used adsorbents have been applied as soil stabilizers and slow-release fertilizers, as I mentioned before, for strawberry and spinach. Although it's just a lab scales, the process can be enhanced and improved for larger scale application, as this can avoid large wastage and of valuable adsorbents after the adsorption. It's usually one of the practical solutions they actually did. They just dump the adsorbent after it is no longer can be used or it is burned. So this has caused a lot of wastage. All right, so that's all. Thank you.
Thank you very much. Thanks for the nice and informative presentation. I don't know if there are any question here. Are we all good here? All right, thank you very much, Ms. Safi. Thanks. Our next presenter is Rania Remani from Algeria. She will be presenting a paper about the Algerian contaminated groundwater treatment by using acidic gum, organic pollution removal. It's a very hot and interesting topic. Ms. Remani, if you can share your screen, please.
Sure. Good morning, everyone.
Good morning.
Yeah.
You have 10 to 12 minutes, so if you can kindly stick to the time, please.
Okay, thank you. So, hello everyone, welcome to my presentation in the International Chemical Engineering Conference cited by Characterization and Using of Acacia Gum as a Bioadsorbent for Organic Contamination Removal, presented by Rania Remani. So, according to the results of the increasing of toxic pollutants in water, there exists a direct major concern toward funding particle solutions in order to reduce its damage effects on the environment. Furthermore, it protects human health and environment in the same time. In this context, several technologies such as photocatalysis, advanced chemical oxidation, and membrane separation technologies, and adsorption processes were developed. The basic term of adsorption shown in figure number 1 in Actually, in wastewater treatment, absorption of organic solids has been a primary concern in recent years. So, acacia gum as natural adsorbent is a complex arabino galactan type polysaccharide, which is obtained from the stem and the branches of acacia tree. Acacia trees are abundant in central Sudan and in the central and the west of Africa, and tropical and semi-tropical areas in the world. Even though there are more than 1,000 species of the genus of Acacia gum, only 2 are significant for commercial purposes. Acacia gum is widely used by industries for its neutral, pharmaceutical, cosmetic, and surface properties. Due to the biological properties of acacia gum, it may be an efficient agent in water treatment with the adsorption process, also in high solubility in water and relatively low viscosity compared with the other gums. The objective of this work was to show the capacity of acacia gum powder as naturally efficient adsorbent through organic water pollution removal from Algerian groundwater in the area of Elisi by adsorption phenomena, method and materials. So we will start by the acacia gum preparation. The used acacia gum was obtained from the commercial source. Acacia gum powder was prepared by grinding and sieving to a minimum size less than 50 micrometer and was dried at 40 Celsius degree for 72 hours. For acacia gum powder characterization, XRD and FTIR were used. Groundwater part. The groundwater samples for the study were locally contaminated from Elite region at Algeria. I put the DMS coordination. So this groundwater have been polluted with oil by extraction from the local wells. So this picture showed the schema of the treatment. So the results, we will start with acacia gum characterization. So figure number 5 showed the X-ray diffractogram of the acacia gum, which make this powder totally amorphous material that had no mineral composition on it. The FTIR, the FTIR study, which is shown in figure number 6, of this adsorbent of acacia gum show the presence of band between 3,500 and 3,600, which is correspondent to the free hydroxyl groups OH of the water, and the other peak around 2,852 and 2,900 corresponding to the CH band of aliphatic CH2 groups, another peak around 1,730 and 1,750 corresponding to CO band of aliphatic aldehyde groups. The appearance of symmetric and asymmetric COO bands at respectively 1,600, 1,700, and 1,420 and 1,500 indicate the presence of COO. The presence of the band, the last band, at 1,080 and 1,220 of the CO elongation vibration indicates the possibility of the ester appearance. So the other part of the results related to the groundwater before and after the treatment. So the pH characterization, table number 1 shows that before the pollution of groundwater, pH was 7.68, which is normal value for irrigation water. Actually, the groundwater in this area was used for irrigation only, not for drink. The polluted groundwater pH value was 5.50. That means this water is a polluted water, owing to the standard value of the pH for irrigation water, which is always between 6.5 and 9.5. But after the treatment, we obtained that acacia gum improved the pH value to 6.7. And the results value was normal for irrigation. The second part for the groundwater characterization related to organic pollution removal, the filtration process showed the high capture of adsorbent powder particles and other grain contaminants in the wastewater after the adsorption treatment. Yet this physical separation method cannot eliminate all the quantity of acacia gum due to the acacia gum solubility in treated water. For this case of study, a specific method was used to characterize groundwater before and after the treatment. Table number 2 and figure number 7 show the acacia gum had high removal efficiency due to the reduction of UV absorbance of each wave length related to the organic pollution. The experimental results indicate the presence of carbon-carbon conjuncted bands of the petroleum molecule structure at the range of 200-260. This high gap of UV absorbance were because the petroleum removal efficiency by acacia gum absorbance. So this is the table number, This is table number 2, which show the UV absorbance before and after the treatment, and figure number 7, which show the absorbance of groundwater before and after the treatment. Finally, the groundwater classes for irrigation. As shown in figure number 6, which is Wilcox diagram obtained from diagram software. The diagram converted study sample indicates that this water presents the values from 53% and 62% of sodium percentage. Even though this high sodium percentage are undesirable because its reduction of water quality, all samples were classed as excellent for irrigation. It can be concluded that organic pollution of the used adsorbent didn't change the class of irrigation of the study's groundwater samples. Conclusion. The aim of this study was to investigate the efficiency of organic pollution removed from illicit groundwater in the area of Algeria using acacia gum powder as a bioadsorbent with the pre-treatment on. So that this prepared adsorbent has no mineral composition. Furthermore, the FTIR analysis completely proved the XRD results. Furthermore, the adsorption behavior of produced material was tested by performance batch adsorption tests in contaminated water samples using a ratio of 1:1 for 24 hours. Groundwater analysis indicates that the acacia gum improved the pH value of control and removal of high quantity of organic pollutants. Additionally, the treated water sample has the same excellent class suitable for irrigation applications according to the Wilcox diagram. In consequence, the present study suggested an effective, eco-friendly, and economical adsorption processes. So, thank you.
Thank you very much. Thanks, Dr. Rania.
Okay, السلام عليكم.
وعليكم السلام ورحمة الله. Dr. Tamer, you have about 10 to 12 minutes, so if you can kindly share your screen.
Okay, دكتور.
Dr. Muhammad, are you with us? Professor Muhammad.
Okay, دكتور. واضح السلايدات؟
Yes, clear.
Thank you.
The floor is yours, Doctor.
بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد. شكرا جزيلا لجميع اللجان التحضيرية المشرفة على المؤتمر، وبارك الله في الأستاذ الدكتور زكريا واللجان على دعوتهم للمشاركة في هذا المؤتمر. وأنا حقيقة مستمر في معظم الدورات اللي أحرص على المشاركة. الlecture is titled Available Technology Treatment Method of Oil Field Produced Water. هنالك أكو مشكلة كبيرة تنتج من أثناء استخراج النفط الخام، وهو الماء المصاحب لعمليات استخراج النفط أو الغاز. فلذلك البروديوست ووتر كمياته جدا كبيرة تنتج مع الكرود أو الكرود أويل أو الغاز، اللي هو is defined as the water that is produced as byproduct along with the crude oil and natural gas. It is well known that oil will produce large volume of water and hydrocarbon with oil. لذلك, therefore, the need arises to treat this type of water must be treated in order to reuse again. For example, injected into the reservoir to assist force the oil to the production well. There are a number of reasons for the interest in oil field, because there is a lot of water produced, for example, in Iraq. فالعراق بلد نفطي، وكثير من الآبار الموجودة في شمال العراق وفي جنوب العراق وفي الوسط، فتنتج كميات كبيرة. For example, in Iraq, the average ratio of water produced to oil produced in Basra, as water to oil 1:5. أحيانا ممكن يكون كل برميل استخراج برميل نفط أحيانا تقريبا أقل 10 أو 10 براميل مي. فلذلك جدا مهم الاستفادة من هذا الماء المصاحب. هنا produced water as any water that is present a reservoir with hydrocarbon, produced water to the surface with crude oil and natural gas. The fact that produced water contain a number of undesirable toxic component, different component or pollutant. For example, typical structure of well shown in the figure. This is how produced water with oil or discharge with oil. The most produced water as salinity water. High Ta conductivity may be more than 1,000 part or 10,000 part per million, or maybe reach to the 15 part per million. And practically the produced water must be treated to remove a harmful contaminant. Therefore, removing oil and suspended solid from produced water, an important aspect of pollution to protection environmental. The composition of produced water, mainly oil or other pollutant, such as dissolved organic or heavy metal or dissolved mineral and other. For example, take the sample from Southern Oil Company in Basra. The composition or characteristic of produced water have pH or UC conductivity 120,000 microsieverts per centimeter, or total dissolved solid high, and COD or oil. Water represents by far the largest byproduct and re-injected back into the formation from whence it came. Oil and gas operator routinely injected water into petroleum formation to maintain why? To maintain reservoir pressure and to displace oil to a production well. Globally, maybe 250 million barrels of produced water daily from both oil and gas. Operating unit re-injected to well 55% and other to the environment. Therefore, نصور الحجم الكمية الكبيرة للماء المصاحب لاستخراج النفط. The following figure below show increasing production of produced water through years from up to 2014. هنا البلوك الجرين بلوك اويل برودكشن. فنلاحظ البلوك البلو بلوك يجد اكثر more than the block green block higher water production and other water maybe in with well or with rocks depend on the geometrical of the well. And then how to find how to use this to use this produced water. There are different ways, but the most important, reuse in petroleum industry operation. Treated produce may be used for drilling and workover operation, or other uses for irrigation or for cooling or other uses depend on the required reuse. Other slide, there are different technology method to treatment of this produced water to find or to receive suitable quality for meeting the purpose where the produced water reuse. Therefore, to reuse produce several operation technology to meeting the purpose where the produced water reuse. Therefore, maybe there is conventionally treated by removing the suspension and floated oil injected to oil zone for enhanced oil recovery. But the general treatment method to treatment the produced water or to treated oily wastewater or petroleum industry wastewater, there are different classification classified as the primary or secondary or tertiary when you use the produced water to high quality of water. This is the primary sedimentation, separation, filtration, or calculation, flotation, and this is the secondary, and this is the tertiary treatment to produce water, high quality water, applied advanced treatment, for example, distillation or by ionic exchange or by reverse osmosis. In this lecture, we applied some technologies from this classification, such as calculation, flotation, and ionic exchange, or by membrane or by flotation. The mechanism of how you can remove the oil or suspended from produced water, or how you can remove the collide particle or the oil. This mechanism depends on the type of charge, and there is repulsive force between between particle and other particle. There are قوة تنافر repulsive عالية because the Brownian motion has negative charge. This is the theory of Guy double layer, Guy and Stern has negative charge. Therefore, there is repulsive force between collide. Must be, to remove this particle, must be neutral the charge, or by adding the chemical coagulant, because naturally flocculation or a Brownian motion is poor to attractive this collide with other collide. Therefore, this is, you must be decrease the zeta potential or the repulsive force, and to increase the van der Waals forces. In University of Technology, الجامعة التكنولوجية، وفي قسم الهندسة الكيميائية، من خلال طلاب الماجستير والدكتوراه, we take different cases for sample of produced water, من خلال التعاقد مع وزارة النفط، شركات وزارة النفط، لنأخذ كيس من مواقع مختلفة من الآبار النفطية، وناتشرالي هذا الكيس ممكن احنا نجي نعالجه. للغرض من عنده هو إزالة الأويل وإزالة التيربيديتي حتى نقدر ري انجكشن. وأحيانا ناخذ اندستري بتروليوم ويست ووتر أيضا ريموفال أويل أند تيربيديتي حتى نوصل إلى الكواليتي اللي ممكن نستعيد استخدامه. العفو. فهذه التكنولوجيا مختلفة أخذنا من آبار حقل الرميلة بجنوب العراق وشركة الوسط، أو من نفط الشمال، أو من مياه مصاحبة بجنوب العراق. فهذه النماذج naturally case study، أو أحيانا يتعذر علينا ناخذ الناتشرال، ممكن نسوي artificial oily waste produced water. فلذلك القصد من هذه العمليات من خلال البحوث اللي أجريناها في الجامعة التكنولوجية هو إنه حتى نحصل على turbidity less than 10 parts per million or oil less than 10 parts per million اللي هي meeting with quality water to re-inject it. Maybe
Professor Mohammed, if you can kindly conclude in about 2 minutes.
Oh,
so we won't
by calculation, flocculation, or sedimentation, or flotation, or adsorption, or as alone, or combination. For these technologies, by flotation and these technologies by electroflow-calculation to receive, to find, or to reach the higher efficiency. This is the different technologies, adsorption and other method by dissolved electroflotation and other by induced air flotation, and this is the hydrodynamic bubble column, and other technologies for natural coagulant or chemical coagulant. اللي قدرنا بالبحث الأخير أنه نستخدم مواد لبعض البذور الباذنجان أو البصل، فقدرنا نحصل على high efficiency of removal oil. هذه هناية اللي حصلنا فيها بيتنت من وزارة التخطيط، براءة اختراع باستخدام مواد هناية هذه اللي استخدمنا بها بذور ناتشرال، وقدرنا أن نحقق هاي افشنسي لإزالة جدا عالية 100% تقريبا بهذه البحوث. واستخدمنا أيضا الأكتف كاربون. فهنا ملخصة أنه حتى نحصل على high efficiency of removal oil and removal turbidity or suspended solid. وهذه هنا الخلاصة أنه إحنا دائما نحصل على أويل أقل من 10 أو حدود 5 بارت بير مليون من الأويل والتيربيديتي. ونشرناها هنا، طالبة اشتركت وحصلت على أحسن بحث في إنجلترا في خلال مؤتمر، وهذه البراءة الاختراع وهذه البحوث اللي نشرت في مجلات عالمية. وشكرا جزيلا.
Thank you very much, Professor Muhammad. I will leave the floor for the audience if they have any question. Yes, we have one here.
The question is, do you have an idea how to remove some sort of suspended solid or some insoluble from brine, from saline brine, such as the Dead Sea brine? Thank you.
Okay. The saline water can be, to removal salinity must be applied membrane separation, reverse osmosis. But for re-injected in well, there is no problem in salinity. The problem mostly in oil content and turbidity in produced water. Must be removal oil and turbidity. But if you can remove salinity, must be applied other advanced treatment to reuse for maybe drinking or other uses. But for flocculation or flotation or not to remove the salinity. Possible applied membrane.
Any other question? Professor Muhammad, I have a question for you actually. In your presentation, you mentioned something about the, I think it was 5-to-1 ratio of water to oil. Are you with me?
Okay.
In one slide, I guess you mentioned that the water is used
1 to
is
5.
5-to-1.
There is a huge amount of water with crude oil.
So the one is what? The oil to water or water to oil? This one.
This is oil, water
to
more
oil
than
ratio.
the oil discharge.
Oh, that's a huge amount of water, right?
Well,
For the separation, is it a common practice to reuse this generated water instead of going all the way to treat it?
What?
Because they do use some water for injection to keep the pressure, right? So
Yeah,
can this water
to maintain the pressure for discharge crude oil, and the quality of re-injected water must be contain less than 10 parts per million of oil content and less than 10 parts per million of turbidity to re-injection in well.
is there a reason for that? Or there must be one, but what it is?
What?
I'm just curious. It's very interesting. I mean, in Jordan we lack oil, so we're not very familiar with the petroleum process and the extraction process. So
This technique applied now only by flotation to remove. But if applied copulation, flocculation, or adsorption, or by to reach to higher efficiency of removal oil to re-injected, but not only applied flotation to reach the high quality of produced water. Therefore, must be have less than 10 parts per million to reuse.
all right, thank you very much. Thanks.
Okay, thank
Any
you
other
very
question?
much.
Oh, thank you very much, Professor Muhammad. We'll move to our next
Thank you, thank you.
speaker, Dr. Salman Nagafi from Pakistan. Are you with us? Seems that he's not here. All right, we'll move to Dr. Shady Sawalha.
Good morning.
Dr. Shady Sawalha, are you with us?
Yes. Yes.
Yep,
I'm
Dr.
here. You hear
Shady.
me? Okay.
Can you hear us clearly?
Yeah, I hear you clearly. Do you hear me clearly?
Can you share your screen, please, and your presentation?
Okay.
All right, so
Clear now.
our next speaker is Dr. Shady Sawalha from Jamiat al-Najah, University of Najah in Palestine. He got his PhD degree in material engineering and nanotechnology from University of Salento in Italy. His research interest is in synthesis and development of carbon nanoaltropes in energy, environment, and medical applications. His presentation titled as Photodegradation of Methylene Plubicarbon Nano Dot Synthesized from Olive Solids Waste. It's a very interesting title. Dr. Sawalha, the floor is yours. You have about 10 to 12 minutes, so if you can kindly stick to the time, will be great. Thanks.
Okay. Thank you very much for
Go ahead.
presenting me. And now I will present my presentation, my work, which is about photodegradation of methylene blue bicarbon nanodots synthesized from olive solid wastes. This work is done by me and my research group here in Palestine at the Najah University, the chemical engineering department. First of all, I will show you the contents. I will talk about the work objectives.
Dr. Sawalha,
yes?
can you raise up your volume, please? Your voice it wasn't clear. So
Okay,
if you can
try
speak
now.
up. Yeah, now perfect.
Clear now? Okay. So the problem was from the mic.
Yeah, thank you.
Okay. So my presentation is about the photodegradation of methylene blue bicarbon nanodots synthesized from olive solid wastes. This work is done by me and my research group here at the Najah National University in the Department of Chemical Engineering. First of all, I will pass through the contents of my presentation, which will contain the following: work objectives, then a brief introduction about the topic, and the synthesis and characterization of carbon nanodots, and then the application of these carbon nanodots, photodegradation of methylene blue, and finally the conclusion. The objectives of this work is to synthesize carbon nanodots from olive solid waste by pyrolysis and chemical oxidation method. Here, the olive solid waste is collected from the local market in Palestine as a byproduct after the squeezing of olive into oil. Then the synthesized carbon nanodots have been used as a catalysts in order to remove organic pollutants such as methylene blue from water through photodegradation process. And during this process, we need to study some parameters that may affect the degradation process, such as the photocatalyst dose, the pH of the solution, the molecular concentration, source potential, and the location of this source, and also the salt content. Through the calculations of the most important parameters to be monitored here, the photodegradation efficiency and the rate of degradation. First of all, I will introduce briefly about carbon nanodots. Carbon nanodots is a new class of carbon nanoallotropes which were discovered recently in 2006, suddenly through the purification of carbon nanotubes. These carbon nanodots have size less than 10 nanometer. Some of these carbon nanodots can be hybridized as sp2 or sp3 or a mixture between both types of carbon. So we may find carbon nanodots as amorphous or crystalline in some cases. These carbon nanodots may be produced or synthesized through different routes, like top-down approach or bottom-up approach. In the top-down approach, there are some methods like the arc discharge, laser ablation, and other methods. In the bottom-up approach, the combustion route, microwave, and so on. In our work, we use combination between two methods. We use the bottom-up first, and then the top-down, as we will see in the materials and method part. These carbon nanodots can be applied in different applications due to their good properties. So we can use them in bioimaging, sensor, photovoltaic, and other applications. And here we use them in photocatalyst application. Here I will talk about the synthesis and characterization of carbon nanodots. First of all, the solid waste, or the olive solid waste, which is called, maybe called pomace, or here in Palestine and Jordan, we know this product as Jifet. It's a byproduct from olive industry. It's the solid byproduct from olive industry. Really, in our country, it is used in a way that may harm the environment. So we thought about this procedure in order to convert this into a useful product and a new product. First of all, these olive solid waste were biolyzed to carbon-based material, as you can see here, and then so this step can be considered as a bottom-up. We convert these molecules into carbon particles, then we extract and oxidize these carbons into carbon nanodots by refluxing them in the presence of an oxidation agent like the hydrogen peroxide. The produced material or the produced particles here, carbon nanodots, with a size about 2.8 nanometer or about 3 nanometer, with a well dispersion of these carbon nanodots in the solution, where the solution was water. So the water was the solution or the media where these carbon nanodots were dispersed. Further characterization includes the FTIR or the IR spectra, as we can see here. Most of the functional groups are oxygenated groups, and this gives these carbon nanodots the ability to be dispersed or will dispersed in water, and they have also a negative charge. Furthermore, we studied the fluorescence characterization or characteristics of these carbon dots. We noticed that these carbon dots are fluorescent and they are excitation dependent. These carbon quantum dots have about 3% quantum yield, and this number is good when it is compared with other biomasses that were converted to carbon nanodots. The photodegradation of methylene blue, a solution of methylene blue was injected with 5 100 microliter of carbon nanodots with a known concentration. And then the absorbance was monitored for 120 minutes every 10 to 15 minutes. We read the absorption, and we can see the drop in the concentration or the drop in the absorbance with time. In order to check if these carbon nanodots behave as photocatalyst or catalyst, we inject these carbon dots, and we monitor the degradation, let's say the degradation with time, and we see no effect of these dots in the dark. So here we conclude that our carbon nanodots are photocatalysts, not a catalyst. They work perfectly under light, and they don't work in the dark. Furthermore, we studied, of course, the degradation efficiency, and we changed the dose to see the effect of those on the concentration, on the degradation efficiency and the degradation rate that we will see in the next slide. We can see here that without carbon nanodots under light, there is a small degradation of the methylene blue, but with the carbon nanodots, we can see here with this concentration, and then it will increase by increasing the concentration. We get about 86% of degradation, okay, after an addition of 6.67 milligram per liter for these carbon nanodots. Furthermore, we studied the degradation rate, and we assumed that our degradation rate follows the linear Herschel dynamic model. And after linearizing, we can see a linear relationship, and the slope of this linear relationship can, let's say, give an information about the rate. Also, the rate is increased by increasing the concentration of carbon nanodots, with an increase from about 0.011 to up to 0.022 after the increase of the concentration to 6.67 milligram per liter. Sorry. We studied the other factors, or the factors affecting the degradation. For example, we studied the pH effect, and we noticed that an increase or a dramatic increase of the degradation efficiency could be observed at the pH of 10.6. At the same time, also the degradation rate increased from about 0.02 for neutral conditions up to 0.06 under the basic condition, and this can be attributed or related to the hydroxyl groups that may be found, and these hydroxyl groups may affect the, let's say, the defect or the surface situation of the carbon nanodots, and in this case hinder the recombination of holes and electrons, which are responsible in converting the methylene blue into CO2 and H2O. Other factors were studied, like the concentration of NaCl. We see a decay in the degradation rate upon the increase of the salt, and here the salt may prevent from the beginning the formation of holes and electrons. Also, the power of the light source was studied, and we find a relation between the power and the degradation efficiency and the degradation rate. Furthermore, we studied the distance of the light source, and the distance also has an effect on the degradation efficiency and the degradation rate, and that, of course,
Dr. Sawalha,
yes.
If you can kindly conclude it in about 2 minutes, so we won't delay
Yes,
other speakers.
less than 2 minutes. Yes,
Sure,
yes,
thanks.
less than 2 minutes.
Thank you.
Okay. Here we studied the distance, and the effect of distance and power are the same. And here we have certain photons that can arrive to the solution, and these photons are proportional to the distance and to the power. Finally, we studied the concentration of the initial concentration of the pollutant itself, and we find that when the concentration is low, we have high degradation efficiency, and we have high also degradation rate. Finally, we can conclude the following, that we successfully synthesized an efficient visible light photocatalyst carbon nanodots was partially prepared by a combination of bottom-up and top-down routes using pyrolysis and chemical oxidation methods. The synthesized carbon nanodots was fluorescent with about 3 nanometer size. The photocatalytic activity of these dots was monitored through the degradation of methylene blue dye after radiation of yellow visible light for 120 minutes. And several factors were studied, like those with an increase from 0.02 to 6.6, with a degradation rate of 0.02 at 6.67 milligram per liter. Also, a great effect of the pH on the degradation rate and degradation efficiency, and also there is an adverse effect of the salt content and the pollutant concentration on the degradation rate and degradation efficiency. Also, we found that the power source and position affect the degradation rate and degradation efficiency. Thank you for your attention.
Thank you very much, Dr. Sawalha. Thanks for the very smooth presentation. I don't know if you have any question here. We have room for one or two questions. You have Dr. Linda. She has a question for you.
Okay.
Thank you, Dr. Sawalha, for your presentation. I have some work on the olive mill wastewater. I want to ask if you expect this nano dots to be effective in biodegradation of phenols, which is the main contaminant in the olive mill wastewater.
Yeah, I think it's worth it to try to use them. I think no one at the moment used carbon nanodots in the degradation of phenol. Here the idea was, I took the idea that several researchers used carbon nanodots from other resources for the photodegradation of the methylene blue. Most of them focus on this pollutant, let's say. But I think it is worth it to try to use them as a photodegradation or photocatalysis for the degradation of phenol.
هو اللي خطر لي انه ممكن نستخدم الجفت يعني خلينا نحكي كل مخلفات الزيتون من الجفت ان تعالج نفسها بنفسها، يعني تعالج ميه الزيبار، لانه احنا عارفين قديش في مشكله بالميه الزيبار. فممكن هذا يعني نتواصل بشكل مباشر معكم دكتور. السؤال الثاني الافكتيف تمبريتشر، هاف يو ترايد انه هل بياثر لو رفعنا التمبريتشر شوي مثلا ل 40 50 ممكن انها تحسن
درجه حراره السوليوشن
انه يصير رياكشن؟
اكيد درجه حراره السوليوشن اكيد راح تعزز اللي هي دور الكربون نانودوتس. ممكن هنا كمان تساعد في عمليه اللي هي تكوين الهولز والالكترونز. احنا الاساس يعني عندنا شغلتين مهمه، لازم انه ننتج اللي هم الهولز والالكترونز بوجود اللايت، ونمنع عمليه الريكومبينيشن السريع لهم. فبالتالي درجه الحراره بتعزز تكوين الهولز والالكترونز، وبرضه كمان شغله ثانيه بتاثر سلبا على اللي هي البونز الموجوده بالميثيلين بلو. فبالتالي اكيد درجه الحراره راح يكون لها دور، بس احنا حاولنا نعمل هذا الشيء على روم تمبرتشر، يعني ما حاولنا انه نغير درجه الحراره.
تمام، هو اذا كان على روم تمبرتشر اكيد احسن. شكرا كثير دكتور، نتواصل معك ان شاء الله.
شكرا لك، شكرا لاسئلتك، شكرا لكم جميعا.
Thank you very much, Dr. Sawalha. Next is our presenter from India, Madhumita Manna. I hope I'm pronouncing your name right.
Yes.
Oh, all right. She will be presenting a paper about the emerging and sustainable technologies for wastewater treatment from a current and future perspectives. The floor is yours, the mic is yours, so you have 10 to 12 minutes. If you can kindly stick to the time.
Is it visible my screen?
Yes, I think that's your presentation. Yeah, we can see it.
Is slides changing? I don't understand. Shoot.
Yeah, you may start.
Yes, sir, I'm sharing my screen.
I'm sorry?
I'm sharing my screen. Is it visible?
We can see your screen, yes. You may start.
Okay, sir, but is it changing or not? I don't understand. Okay. Sir, one.
Ms. Mana?
Sir, huh?
Yeah.
So I am Madhumita Manna.
We can see your screen. If you can present the slideshow, it will be great. So we'll have a better view of your presentation. Yes, please.
Yes, sir. Now
Yeah.
it's visible, na? Yes.
Yeah, it's clear.
Okay. Thank you, sir. So
You're
my
welcome.
topic is emerging and sustainable technology for wastewater treatment, our current perspective and future direction. I'm a PhD scholar from National Institute of Technology, Rourkela, Odisha, India. I'm doing PhD under the guidance of Dr. Shujit Sen from Department of Chemical Engineering. Starting with the wastewater generation volume at a global scenario, according to acoustic database of Food and Agricultural Organization, it estimates that the freshwater withdrawal rate is 3928 kilometers per year, and out of which 44% is utilized by agriculture, municipal and industries, and other 56% is released as wastewater. According to UNESCO UN report 2020, industrial water demand will exponentially increase to 24% by 2050. And more scary thing is that over 80% of wastewater discharged into the environment with no or inadequate treatment. This is the estimated industrial water demand hike from 2010 to 2050 continent-wise. Overall, it is 24%. This is the emerging technology present for wastewater treatment. I will only highlight few technologies because of the time limitations with their practical applications. Starting with hybrid membrane technology. It is advantageous because it utilizes the synergy of integrated process to solve technical and economic limitations, which can't be possible by standalone process. As for example, membrane bioreactor. It can be aerobic or anaerobic. Anaerobic microbial bioreactor system has been successfully commercialized to treat dairy, brewery wastewater in several countries like South Africa, Germany, etc. Because it has a low energy requirement, it's a high organic loading rate capacity, environment friendliness, and its energy recovery from biogas. Its energy feasibility from biogas, it's applied for Mars factory, which is situated in Weigel, Netherlands, is the largest chocolate factory in the world. Used membrane type anaerobic membrane bioreactor to produce 1 lakh meter cube of biogas, which covers 10% of its total energy requirement of the plant. Considering the current world trend for wastewater treatment is based on the process intensification. Here comes as the integrated process. These integrated membrane processes are very feasible for this process intensification terms, such as AOP-MBR, that is Advanced Oxidation Process Membrane Bioreactor, which followed by membrane bioreactor can mitigate membrane fouling and remove refractory compounds as well as dyes and heavy metals. MDBS system, that is membrane distillation bioreactor, which is able to capture heat for electricity generation. And integration of reverse osmosis with membrane distillation is capable of removing heavy metals as well as concentrating ammonia from synthetic metallurgical industrial wastewater. Now, application of nanotechnology. Nanotechnology deals with the nanomaterial which has a dimension of less than 100 nanometers. This nanoadsorbent has a high specific surface area than the macro scale materials. And nanoadsorbents such as carbon-based nanomaterials, metal oxide-based, polymer-based, which are very efficient for removal of dyes and heavy metals present in wastewater. Its commercial application belongs Arsen X and Adsorptia. Arsen X consists of iron nanoparticles, and Adsorptia is nanocrystalline titanium dioxide medium. Both are used for arsenic removal from water. Next is membrane technology. In any membrane process, the main hurdle is the membrane fouling, and nanomaterial based membrane is efficiently overcoming these limitations too, because it has a self-cleaning properties. Additionally, it has higher selectivity, higher permeability, and higher chemical and thermal stability. Nanofiber membrane has been commercialized for air purification, though its application in wastewater treatment is yet to be explored. For example, thin film nanocomposite, these are useful as it has a higher salt rejection capacity that over 99.4% than the conventional RO. Next, in the field of disinfection and microbial control. Nanomaterials like nano silver, nano zinc oxide, nano titanium oxide are useful for efficient disinfecting and antimicrobial purposes. As because it doesn't possess any disinfecting byproducts which are generally formed by conventional disinfectors like chlorine, ozone, etc. But its long-term efficacy is challenging since nanomaterials form biocidal ions over the time. The studies on controlled release of nanomaterial is utmost research need. It can be done by encapsulating nanomaterial with a matrix coated material which will only give response upon the presence of target microorganism. Next is the sensing and monitoring field. In detection of organics, trace organics and pathogens present in wastewater is very challenging for detection by the conventional coliform bacteria indicators. That's why quantum dots can act as a photoluminescent nanosensors for detection of toxic chemicals like phenolics, drugs, pesticides, etc. Even noble metal nanomaterial, that is nano silver or nano gold, which are also useful for sensing and monitoring purpose, as because it has a unique surface plasmon resonance phenomenon. Next is emerging contaminants removal. Emerging contaminants are now new burden to the quality of the water, and contaminants can neither be detected nor be depleted from water by conventional water treatment processes are called emerging contaminants. These are pharmaceuticals, personal care products, pesticides, hormones, etc. Therefore, strategic control and removal technique has to be adopted. First is the source control. The main point source of the contamination to the surface and groundwater is found to be the outflow of the treatment plant from industrial, agricultural, wastewater treatment. What is its remediation? This can be done by setting rules and regulations for CEC disposal that would trigger the industries to add a polishing unit in the wastewater treatment. Otherwise, it is very difficult to detect thousands of CECs in the surface or groundwater system. Though techniques are available for CEC removal, that is integration processes of advanced oxidation process, membrane filtration process, bioremediation process, which are very useful. A patented research study reveals that 39 highly concentrated CECs, including pharmaceuticals and personal care products, industrial additives, are by biological treatment followed by continuous ultrafiltration is very useful, and it has a very high efficiency of removal. Next approach is non-structural approach. Non-structural approach are indirect method for remediation of environmental pollution. This can be done by public awareness through educational campaign, setting control and discharge standard by government through consultation with industries and researchers, and different financial and non-financial incentives for to promote green products, technologies, and economic feasibilities. Next is resource recovery from water. Wastewater consists of 20% of its chemical energy and 80% of thermal energy, and these energies can be recovered and reused. Thus, it fits into the concept of circular economy for wastewater treatment. Nutrients like nitrogen and phosphorus can be easily recovered from wastewater and by several processes, that is precipitation, ion exchange, adsorption, etc. European Union has the highest number of phosphorus recovery plants, followed by North America and Japan. Similarly, nutrient recovery, in case of energy recovery, European nations are the leader for waste to energy movement. From this graph, we can see that if we increase the treatment value proposition, recovery value proposition will increase. That is water from for irrigation to potable water. Therefore, we can estimate that resource recovery from wastewater will increase the economic benefits, and these benefits will further enhance by addition of any additional advanced treatment technologies and its management. In conclusion, we can conclude with that the wastewater should not be considered as waste but a valuable resource, and sustainability can only be achieved by definite goals. That is production of high quality effluent satisfying strict discharge legislation, upgrade existing treatment system by retrofitting with the innovative technologies, water reuse and energy recovery under the concept of circular economy. Cost should be balanced with the energy profit. It should have a low environmental footprint. Non-structural approaches are public communications, awareness campaign, broader participation, and educational program that has to be included as an integral part of the development and decision-making framework. A transition from linear model to circular economy will synergize more efficient water use and enabling economy to counterbalance between the ever-increasing water demand and supply ratio. Thank you. These are my references.
Dr. Manna, there's a room for one or two questions. Anyone have a question?
Yes, I have a question for Dr. Mina.
Yes, sir.
Yes. Have you included any, this is regarding the hybrid membrane technologies, have you included any hybrid membrane technologies where membrane is hybrid with adsorption process? And if it's included, what is the limitation?
Ma'am, actually, this is our review process, so I didn't mention any particular process in hybrid technology. Hybrid can be done in many processes like adsorption with bioremediation or photocatalytic degradation. So if it is so, we can, first we can check the efficiency of the individual process, and we can integrate it. After integration, we can check its efficiency too.
Okay, thank you.
Okay.
Any other question? Thank you so much, Dr. Manna.
I have one
Yes.
question. Sorry.
Yes, please.
What is the difference between integrated process and hybrid process?
Okay, integrated process means there is two process we are integrating. It can be done by a parallel combination or series combination. Anything is integrated process. That is the individual process intensity or efficiency will be there. But in hybrid process, we are combining two method in such a way that we can't differentiate its efficiency. We can differentiate it, but overall we can get an efficiency, and that's all.
All right, thank you so much.
Thank you.
Thank you again, Dr. Manna.
Thank you.
I will move now to our next speaker, Dr. Abdelhadi with us.
Hello, everyone.
Hello. So, welcome Dr. Abdelhadi bin Abdel Sadouq from Algeria. His lecture will be about lighting up the future new
Yeah.
technologies for smart devices. The floor is yours, Dr. Abdelhadi. Please start and share your screen.
Yeah. Hello.
Dr. Abdelhadi, excuse me.
Light up the future new technology for smart device. Yeah.
We need you to raise your voice a little bit to make it clearer.
Yeah. There is a problem. Yeah. It's clear. The program is definition of organic electric, then organic electric application, then introduce scientific production of original electric. Electronic, organic electronic, it is organic electric are defined a material related to the device. Until some application of a small organic molecule or application that show device electron producing shows as electron devices are reality in their instituted on organic basis of basis on modern carbon besides. Then organic electric application there is many types. Hello. Please. Please. So, organic fire seller, then organic memoir, then OLED, which is our type today, then sun skin health monitor, then organic fire affection content. Organic soil cell, it is a type of photovoltaic cell that using organic electric as it deals with the organic molecule to absorb light and transmission charge to produce electricity from solar radiation by the photovoltaic effect. OLED. OLED is a light imitation, dose is a thin constituent light source with the container. So, I'm sorry because there is a problem for communication. Then the circle OLED is principle of its working. There is the valve contains of two poles on negative and positive, the electron passing through the lever, then photon, then there is a difference between non-materials and glasses. So spectrum mode 2500. So the basis of that determine the color of light in OLED technology. We must choose the type of semiconductor materials and the energy level of the two atoms. Intuitive scientific producer of organ.
It seems there are a bit of a problem or a technical problem with the connection. So if you allow me, we may move to Zakia Djibouti. Is that right? Are you with us?
Yes, Mr.
Ms. Zakia, you can hear me, right?
Yes, Mr. Chairman.
Okay.
I hear.
Zakia is a PhD student at Abbas Al-Ghrour University from Algeria. She is specialized in applied biotechnology. She will be presenting her paper about the evaluation of the anti-inflammatory activity of polyphenols from Algerian monovital olive oil mill wastewater. You have 10 to 12 minutes to present your work, so please stick to the time. And you can start now.
Yes, Mr. Thank you.
Ms. Zakia?
Yes?
If you can start, please.
Okay.
Please.
Can you say my screen?
We can, but if you can move to the
Can I,
slide share,
continue?
the slideshow
Okay.
mode, please.
لو سمحت.
Thank you.
Good morning, everyone. I'm pleased to share with you my work entitled Evaluation of the Anti-Inflammatory Activity of Polyphenols from Algerian Varietal Olive Oil Meal Phosphor. First, we started with the introduction from the definition of olive oil meal phosphor. Olive oil production is a very common activity in Mediterranean countries, including Algeria. These countries face a serious environmental problem because of their wastes, especially the effluent called olive oil meal phosphor. The cause of the polluting power of this waste is its polyphenol content. Currently, much of the attention in research is on the study of polyphenols. Indeed, phenolic compounds exhibit a wide range of biological characteristics, including antioxidant and anti-inflammatory effects. The objective of this study was to evaluate in vitro the anti-inflammatory potential of the phenolic extract of olive oil meal phosphor from two varieties, Shemlal and Zlitni, extracted from a modern olive mill located in Khanshla, eastern Algeria. Material and methods. The samples was taken from a modern olive mill located in Bagay, eastern of Algeria. We take these samples in plastic bottles from 5 liters. The extraction of polyphenols was done by the maceration method after drying the samples. And after this, qualitative phytochemical analysis of this effluents was done. The total polyphenols was measured by colorimetric dosage using Fluorescence method and the flavonoids content using aluminum chloride method. The anti-inflammatory activity was done using 2 tests, the inhibition of protein denaturation and the membrane stabilizing potential. Inhibition of protein denaturation, the basic idea is that the phenolic extract of olive oil meal phosphor prevents BSA denaturation produced by heat. 1 milliliter of each different extracts was added to 1 milliliter of the serum albumin solution made in trace HCl, then incubated in 37 degrees Celsius from 15 minutes, followed by 5 minutes in water bath. After cooling, the turbidity is measured in cell spectrophotometer. Diclofenac sodium standard was produced using the same technique in ultra-pure distilled water from 5000 mother solution with distilled water serving as a negative control. From the second test, the membrane stabilizing potential, an equivalent volume of blood was collected from a healthy human voluntaries who had not taken any NSD from 2 weeks before the blood collection and combined with an equivalent volume of steel acid solution. This blood solution was centrifuged from 10 minutes, then packed with and separated with isosilane solution. After that, after the measured in with a spectrophotometric diclofenac sodium at the phenol concentration was used as a positive control and distilled water as a negative control. The results of phytochemical analysis are illustrated in Table 1. The phytochemical analysis of phenolic extract relieved the presence of alkaloids, phenols, flavonoids, steroids, and tannins in the two extracts of Shimlal and Zlitny, while it relieved the absence of saponins in the two extracts. From the total phenolic and flavonoid contents, the results are presented in Figure 1. According to the results, the content of olive oil in phenolic contents differs between the extracts of the two varieties. And the higher content of polyphenols and flavonoids are in Shimlal variety. From the anti-inflammatory activity, conclusion, the in vitro assays carried out indicate that the phenolic extract of olive oil meal water has an important source of natural anti-inflammatory agents, which can be used in the pharmaceutical industry on the one hand, and on the other hand, reducing its dangerous impact on the environment. And thank you for your attention.
Thank you very much. Thanks for your presentation. I don't know if there are any questions from the audience here. I believe with this, we are reaching to our last presentation from Abir Barqouk from Algeria as well. Abir, are you with us?
Yes, I'm here.
Yep. So, Ms. Barqouk is with us. She's a PhD student at the Department of Material Science, Mohammed Khdair University from Algeria. She will be presenting her work, and the title of her presentation is, it's very interesting actually, I was going through it. It's the Dynamic Mechanical Analysis and Morphological Study of Composites of Polyvinyl Chloride, Date Palm Leaf Fiber. That's very interesting. So if you can start, and please, if you can limit your time to 10 to 15 to 12 minutes, kindly.
Thank you. Assalamu alaikum.
Wa alaikum
Hello. I hope you are doing fine. Thanks for the hybrid 9th Jordan International Chemical Engineering Conference. I will be presenting my work entitled Dynamic Mechanical Analysis and Morphological Study of Composites of Polyvinyl Chloride Date Palm Leaf Fiber. This work is presented by Bartok, affiliated to Applied Chemistry Laboratory, University of Biskra, Algeria. In this presentation, we are seeing an abstract, objective, introduction, preparation of our composites, results and discussion, and we conclude with a conclusion. We started with the abstract. The objective of this research is to improve the properties of polyvinyl chloride polymer. From this, some properties of polyvinyl chloride-based composites containing a natural lost date palm leaf fiber in different proportions were studied. In this present work, composites containing fibers at 10% and 30% by weight were conducted. In addition, we performed a study of glass transition temperature behavior from dynamic mechanical analysis, DMA. We also performed a morphological study followed by scanning electron microscopy. The main objective of this work is to study some properties of polyvinyl chloride-based composites containing natural losts in various proportions that can lead to the improvement of the polymer. And then we move to the introduction. Date palm fibers are reinforcement for fiber-reinforced polymers. Moreover, they are considered as a natural lost. Recently, various studies have been conducted to prepare polymer composites based on the use of the date palm fibers. In order to improve the properties of the polymer, the main objective of this research is to examine some properties of polyvinyl chloride composites containing date palm leaf fiber in different proportions. For preparation of our composites, we mix the date palm leaf fibers with the PVC, the polyvinyl chloride, and we put the mixture in the machine of calendering and compression. Then we obtain a plate of composite polyvinyl chloride date palm leaf fiber. For the glass transition study, we used dynamic mechanical analysis, DMA, and with the morphological study, we use scanning electron microscope. We move to the results and discussion. Firstly, we start with glass transition study. The study of the glass transition temperature of the composites were taken from the DMA curves of these composites, figure number 1. These values have been listed in table 1, where it was noted an increase in TG for the composition containing a rate of 10% by weight of date palm leaf fiber. That is attributed to the increase in the rigidity of the composition, which leads to a decrease in the movement of macromolecular chains. This phenomenon is accentuated for the composition containing 30% by weight of fiber. The temperature reaches 88.93 Celsius. Now we move to the morphological study of PVC date palm leaf fiber composites. According to micrographs B and C, figure number 2, we notice a lot of cavities and agglomerates or aggregates for the 10% composition, and this phenomenon decrease for the 30% composition, so certain cohesion and homogeneity between the polymer matrix and the fiber established for this composition. As a conclusion, this research shows that the dynamic mechanical analysis study of the behavior of polyvinyl chloride, date palm leaf fiber composition, showed an increase in the glass transition temperature value for the composition containing 10% and 30% date palm leaf fiber rate. In addition, our results showed that the same morphology detected cohesion between the polymer and the fiber. Thank you for your attention.
Thank you very much, Ms. Barkook. I think we have some time for 1 or 2 questions max, if you have any question. Does anyone have any question for Ms. Barkook?
Thank you, Doctor. Can you elaborate a little bit on the fabrication of the PVC composite that you worked on? I mean, the method of producing this polyvinyl chloride composite. Can you hear us, Dr. Abir? Dr. Tibi. Ms. Barkook. خلاص.
Ms. Barkook, are you with us? Did you hear the question?
Please.
Ms. Barkook? Well, again, it seems that we're having some technical difficulties. Well, thank you very much all for attending. We're done for the day.
Please,
and yeah.
Please. This is me, Dr. Abdelhadi. Please.
Can you hear us?
Yes. Can I continue on my?
Miss Abdel Sadouk.
Yes, this is me.
You were disconnected for, I believe, some bad connection with us. That's why we moved to the next speakers.
This is problem here in Algeria.
Even now, I can't hear you clearly.
I think I can, yeah. Please. Can I?
Hello?
Okay,
yeah,
okay.
Mr. Abdel Sadouk.
Yes?
I can't hear you.
Yes.
You want to share your presentation?
Yes, so I can.
If you can try now, that would be great. Just please do it quick.
Okay. So, introduce of scientific produce of organic electric there is a biochemical skin like this. It was.
We can't see your presentation, Mr. Abdul Sadduq.
It's not clear.
Oh, we can't see it, no.
You can't? Okay, so.
Billah. Oh, that's your screen?
That's clear? Doctor? Sir?
No, we can't see it.
I don't know.
We only see your screen, but not the presentation.
Yes. It's clear? Now it's clear or now, please? I don't know what's the problem.
Yeah, now we can see it. Just move to the slideshow mode, please.
It's clear? Okay. Yeah?
Yeah, you may proceed. You may continue from the point where you stopped last time.
So, introduce scientific produce of produce of organic electric. There is two examples like biocontaminated asking. This is a very good technology because in medicine because now there is no difficult and no problem for that like the last time in medical. Then smart window. Smart window, it's very good technology. Then we can change light of any room or about the same. At this window, change color according to the water or outside. For example, in the water is sunny. Then this is the reveal. Then thank you for your attention. This is my university. Then
Thank you very much, Mr. Abdul Sadduq. I will just give the chance. I think we have time for maybe a question or two for you, if there are any from the audience.
Okay, welcome.
I think it was clear enough, so we will stop here. And for the audience, thank you very much for your time, for your attention. We will be moving to Hall A for a closing session. So if you can kindly move. Yeah, but it's going to be in Hall A too. Yeah. الدكتور زكريا قال لي في كلوزنج سيشن بعديه. Oh, I'm sorry. Before moving to the closing session, we have a sponsor corner lecture by the Jordan Bromine Company, and it's going to be here. So the presenter is here? Yeah, that's it. Oh, I'm sorry about that. I will give you a couple of minutes maybe to introduce yourself and start your presentation.
Okay, hello everyone. At the beginning, I would like to take this opportunity and thank you for attending my presentation today. I will first introduce myself. My name is Ahmed. I'm a chemical engineer, graduated from the University of Jordan, and got my master's degree also from the University of Jordan. Currently, I'm working as a process engineer at Jordan Bromine Company. Today, I will share with you a water recovery project. But before that, I will introduce my company. Jordan Bromine Company can be considered as the first and only the bromine producer and bromine derivatives producer in Jordan, established in January 1999. We produce bromine and bromine derivatives such as bromine, sodium bromide, calcium bromide, hydrogen bromide, caustic soda, and our plant, bromine plant, can be considered as the second largest bromine plant in the world. Also, we produce tetrabrom, and our tetrabrom plant is the largest plant in the world. Our sales represent about 5.1% from the total Jordanian exports. Our shipments in Aqaba site is about 10% from Aqaba site or Aqaba containers terminals. Our sales are existed in more than 30 countries in the world. Also, we have more than 500 employees, including the nested contractors. About 50% of them are from the local community. Also, we support many projects and investments here in Jordan, and we have about $250 million for supporting these projects. Our company is certified ISO certification standards. Okay, coming back to the project I will talk about, which is the water recovery project. Here, please let me just to outline the project objectives. This project is aimed to reduce water consumption in our site, also water consumption in the whole country in Jordan, especially this year as we face a crisis in water, a water shortage in Jordan. Also, this project aims to generate cost savings, help in plant continuity, to keep the plants running in normal operation, also to improve the water quality, and overall to improve the business growth and development. Here is our project. Simply, we receive water as raw water and fed to our utility section. Our utilities consist of multimedia filters, ultrafiltration, RO units, steam boilers, cooling towers, and softeners. Where from these units we produce steam, cooling water, RO water, and filter water that we used in our production plants in distillation columns, heat exchangers, towers, and reactors. The reject of the streams from our utility area is collected in a water pond. We call it here a fire water pond. Also, the other drains from the plant collected in the fire water pond. From this collection system, the fire water pond, we built a water treatment plant. This plant recovers this water and send it back to our utility area. Here is the sketch for our water treatment. Simply, it's a traditional water treatment plant, sedimentation followed by filtration and RO unit. The benefits come up from this project. Here is the water reduction. This project reduced water consumption in the site with about 200,000 metric cube per year, which is around 20% from the total site consumption. Also contribute positively in the country Jordan, our country Jordan water consumption. Also, this project generates cost savings with about $140,000 per year. And finally, this project improved the water quality as we produce a water with better quality than we receive. That's all, and hope the project generate a good benefits for us as Jordan Bromine Company, also for our country, Jordan. Thank you all.
Well, thank you very much. It's one of the big companies in Jordan, a very important one, and definitely one of the key companies that provide Jordan economy with good points of strength. I don't know if anyone would like to address any question to الباشمهندس. Yes.
يعطيك العافية مهندس. الكواليتي تاع الرو ووتر كومبيرنج للريكفرد ووتر كيف هو؟ يعني انت قلت انه الريكفرد ووتر الان صار افضل من الرو ووتر الفيد للبلانت، صحيح؟ الشغله الثانيه التايب اوف براين ووتر اللي انت مدخله على الريكفري يونت كيف برضه الكواليتي تاعته؟
Okay, for the quality of water that feed to the site, if we look to the total dissolved solids in terms of conductivity, the water enter to the site has conductivity about 2,000 ppm, where the water collected, the brine water collected inside the unit that will be fed to the water treatment plant, it has a total suspended solids in terms of conductivity about 7,000 ppm, as this water is concentrated from the upstream equipment in steam boilers blow down, in cooling towers blow down. This, and also the RO reject stream, the raw water fed to the RO reject stream, RO unit. The reject stream from this RO is sent to the collection system. We call it here the fire pond. The average TDS or conductivity in this fire pond or the collection system, as I said, it's around 7,000 ppm. The unit we built to recover this water reduced the conductivity of this brine water or this feed water from around 7,000 ppm to around 40 ppm only. And that water is recovered 72%. This is the collection, yes, this is the brine water. Yeah, this is the collected water from the whole plant's reject streams, where we want to recover this water and send it back to our utility section. Yeah, this is the reject stream, yeah. Our plant consume around 1 million meter cube per year. Yeah. Cubic meter, yeah, cubic meter. Around 20%, yeah, yeah. Yeah, recycled, yeah, yeah. Yeah, we use it for the same purpose. Yeah, we use it as RO water fit to our steam boiler system. So again, we produce steam for our production processes as I presented there.